For the remainder of this lecture, we'll just consider the three orbitals 1s, 2s, and 2p. But the story that we tell for these three orbitals will be true for other more complicated orbitals. And in the Aufbau principle, 1s gets filled first, 2s gets filled next, 2p third. And if I were to plot that in an energy scale, lower energy orbitals get filled first. Lower energy orbitals get filled first, so 1s must be the lowest energy. Put in chat what's next lowest in energy. 2s. And then 2p must be at higher energy. And 2p is 3 lines because we have px, py, and pz, and it is at higher energy. And this is not the model that this is the Aufbau principle. This is not the model that we taught before. Here the n equals 2, here n equals 1. The model that we had before was the Bohr model. And in the Bohr model, we had E equals 0. And there was low energy 1s, n equals 1. But the formula for energy, E total, was minus RH z squared over n squared. And 2s and 2p, do they have the same n value or different n values? They have the same n value. So in the Bohr model, 2s and 2p, since they all have n equals 2, have the same n value and the z value are at the same energies. The Bohr model works for all atoms with just one electron, which is a small list: hydrogen, helium plus, lithium 2 plus. And the Aufbau principle works for all other atoms. And we want to figure out how to understand the more general case of the Aufbau principle. And the idea is we're going to introduce a new term. The new term we're going to introduce is Z effective. Z effective. Z effective is the charge from nucleus the electron really feels. And so the formula will no longer be the one I had before. The new formula will be ET equal minus RH Z effective squared over N squared. So in the case of 2s and 2p, put in chat, 2s and 2p, do they have the same n value? Yes. So if 2s and 2p have different energies, it's that their Z effective is different. Which Z effective is the smaller number? Put in chat. Remember, E equals 0 on top. Z effective for 2p is less than Z effective for 2s. And so we're going to account for the difference of the energies of the 2s and 2p and the Aufbau principle in the general atom, but by introducing a new concept, Z effective, and if we can explain the different Z effectives, we'll be able to get the differences in energies.